In this video, I'm going to go through some of the problems from the section 2.3 homework. Okay, so I've graded that now, and there were some questions people were having. Okay, so I'm going to start on question 2. I'll do 2A. Okay, so let me stuff here together and grab what 2A says. Okay, so you're going to find the order of growth. Okay, so the order of growth is what we're looking for, okay, of the following. Okay, so in A, we have summation from I is equal to 0 to n minus 1. Okay. Oh, that's the summation, sorry, of I squared. I squared plus 1 squared. Okay, that's the idea. Okay, so we start by just using algebra to simplify this square here. Just I to the 4th plus 2I squared plus 1. Okay, we can now take this, and of course that's the sum is still in front of all this. Okay, so we still have the summation in front of all that. Okay, and we're going to take this now and we're going to split up each part. Okay, it's one of the rules of summations that we can break them up with addition, because if we're just doing addition, right? So there's nothing new there. Okay, so this can give me the summation, and this is going to say from 0 to n minus 1. I'm just not going to repeat it every time. Okay, summation of I to the 4th. Okay, plus, and the 2 is going to be a constant. It's not going to be added to anything. It's going to be multiplied by the sum. So I can do a 2, the summation I squared, plus the summation of the 1. Okay, again, all of these are that from I is equal to 0 to I is equal to 0 to n minus 1. Okay, so now if you look in the back of the book, you can see the following equivalences here. Okay, so I to the 4th is going to equal 1 over, and it's k plus 1, but in this case, the k is equal to 4. Okay, so 1 over 4 plus 1, or 5, times n to the 4 plus 1. Okay, that doesn't erase like I want it to. Okay, n to the 4 plus 1. Okay, plus we're going to bring the 2 out and look up the formula here. It's going to be n times n plus 1 times 2n plus 1 over 6. Okay, plus this last summation is going to be equal to n minus 1. Okay, so we've gotten rid of the summation there. And remember the law that we look at just which one takes the longest when we're doing the adding together here. Okay, so this one is basically going to be a big theta of n to the 5th, because that's going to be the highest power we get from there. Okay, this middle one here is going to be a big theta of n cubed. Okay, the last one is going to be big theta of n. Okay, and when these are all together, we're going to just take the one that is the biggest, it takes the longest. And that's going to be our answer. So the answer to this one is big theta of n to the 5th power. Okay, so that's how that problem works. Okay, so another problem some people had some questions about, we can go over. This is question 4 in the book. there's a clear on this or not. I'm using the Zoom whiteboard for the first time, so we'll see how that goes. It probably is an easier way to clear it, but I don't know it at this point. So we'll just go like that. Okay. So I can be talking while I'm clearing off the board. So this next problem is one of the mystery algorithms. Okay, so it gives you an algorithm. It doesn't tell you what it's supposed to be doing, and you have to figure out what it's doing. Okay. In this case, the basic algorithm here is it's going to have an S gets 0. Then we have a for I going from 1 to n do. And then S is going to get S plus I times I. Okay. And then return S. Okay. So as far as what this is going to do, if you go through a couple cases here, for the 1, okay, 1 S is going to be equal to the 1 plus 1 times 1, okay, which is 1, not which is 2, sorry. 1, it's going to be, no, so S plus 1 times 1, which is 1, okay, so the 1 gives us 1. 2 is going to give us 2 times 2, okay, so 2 squared, and then 3 squared, blah, 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 okay. So this is going to give us, in essence, the summation from I is equal to 1 to n of I squared, okay. So that's part A, that's what this is computing, okay. We're gonna call this S of n, okay. I don't know what that does. Not what I wanted to do. So erase this again. Yes, I'm sure there's a better way. I will eventually find it. But for now, we'll just take the long way. Okay. So that took part of A. Okay. So B then wants to know what's the basic operation. Okay. And if you look at that, the basic operation is going to be that multiplication of the integers. Okay. So of each number to be a square. Okay. C is going to ask us for how many times the basic operation is executed. So that's the C of n. It's going to be equal to a sum of I is equal 1 to n, okay, of 1, which is going to be equal to n. Okay. That gets us to that. Then D is going to be the efficiency class here. Okay. So this gets a little bit interesting. Okay. So we know that this count is equal to n, and that's going to be an element of the big theta of n. It's linear. Okay. But the size metric here on the number is going to be the bits of n. Okay. So how big n is. Okay. So the bits b for n in binary is going to be the ceiling function of the log 2 of n plus 1. So that's how we get how many binary bits that we get. Okay. So we're going to approximate that to be the log 2 of n. Okay. Means n is going to be approximately 2 to the b, just by the definition of what logarithms do. Okay. So if n is that, then we have that our C of n then becomes an element of this 2 to the b. Okay. So it's based on the magnitude of the number. Okay. That's how we're going to get that. Okay. So in any problem that deals with the magnitude of the number is going to be related to that in some ways. Okay. So then the last one, how can you do it quicker? There's a formula. Back book. that you can use. And if you use that, you can get to it directly. And the formula in the back of the book has the big theta of 1. Okay, you just plug it in, and there you go. Okay. So 5B, I'm sorry, 5 is going to be a similar problem. Okay. Still want to erase. I'm not getting. Nope. Double clicking doesn't help. Okay, it's a different algorithm. I won't write that one down. It's in the book. That was a little more complicated on the algorithm. It's got a for loop. It's got some ifs in there. Okay. It turns out that that one is going to compute the difference between the largest and the smallest numbers in an array. Okay. So that's what A will be for us. As far as B goes, the basic operation is going to be okay. I've already said that, so we're good. B, it's going to be the element comparison. Okay. C would have our Cn, number of times that n gets executed, is equal to is equal to 1 to n minus 1 of 2. Okay, 2 comparisons per round through. Okay, which is going to give us 2 the n minus 1 computations. Okay. In this case, on D, we're going to get into the big theta of n. And so it's a limit equation. And then the last problem I'm going to do is problem 9. I'm going to go ahead. I'm going to go ahead and make that a separate video in case you want to get just the one with the inductive